giant wheel, coin, disc, dinner plate. All these are the examples of circle. Today we will study about circles and the properties of circles. Come, let's start. Objectives. At the end of this lesson, you will be able to define radius and center of a circle, identify interior and exterior of a circle, identify chord and diameter of a circle, explain major arc and minor arc, define circumference of the circle, differentiate between sector and segment, explain the angle subtended by a chord at a point, draw perpendicular from the center to a chord, understand equal chords and their distances from the center, explain angle subtended by an arc of a circle, explain cyclic quadrilateral. Definition. Look at this circle, and now look at this dot in a circle. This is a fixed point and is called center of a circle. We can make radius with this point. Radius is the line from the center of a circle to a point on the circle. In this figure, OP is radius. Look at this clock now. It is round in shape, or we can say that it is circular in shape. Interior and exterior of a circle. Circle divides the plane on which it lies into three parts: interior, exterior, and circular region. Let's go through them one by one. Interior. The area inside the circle is called interior of the circle. Exterior. The area outside the circle is called exterior of the circle. Circular region. The circle and its interior make up the circular region. Chord and diameter. If you take any 2 points on the circle, say P and Q, and join them, then the line segment PQ is called a chord of the circle. The chord, which passes through the center of the circle, is called a diameter of the circle. The longest chord of the circle is called diameter. Diameter is the longest chord of the circle and is equal to 2 times the radius. Here we can see that AB is a diameter. Major arc and minor arc. Look at this figure. This is an arc. An arc is a part or a portion of a circle. Or we can say that a piece of a circle between 2 points is called an arc. There are 2 types of arcs: the major arc and the minor arc. The longer one is called major arc. Here AQB is the major arc, and the shorter one is the minor arc. AB is the minor arc. The arc is denoted by this sign. Circumference, sector, and segment. The circumference of a circle is the distance around the outside of the circle. It could be called the perimeter of the circle. There are 2 main slices of a circle: the pizza slice and the slice made by the chord. The pizza slice is called a sector, and the slice made by a chord is called a segment. There are 2 types of sectors: the minor sector and the major sector. Like sectors, there are 2 types of segments: the minor segment and the major segment. Now look at this circle. Here, both the arcs are equal. Therefore, these 2 are the semicircles. Angle subtended by chord at a point. Take a line segment AB and a point C on the circle with center O. Join AC and BC. Here AB is chord and angle ACB is the angle subtended by the chord AB. Also, angle AOB is angle subtended by chord AB at the center. If we draw 2 or more equal chords of a circle and measure the angles subtended by them at the center, then we will find that the angles subtended by them at the center are equal. This relation gives us the theorem which says that equal chords of a circle subtend equal angles at the center. Theorem. Let us prove this theorem. Given two equal chords PQ and RS of a circle with center O. To prove, angle POQ is equal to angle ROS. Proof. In triangles POQ and ROS, OP is equal to OR because these are the radii of a circle. OQ is equal to OS. These are also the radii of a circle. PQ is equal to RS given. Therefore, by SSS congruence rule, triangle POQ is congruent to triangle ROS. This gives angle POQ is equal to angle ROS because corresponding parts of congruent triangle